Hello my friends, welcome back for the programming concepts using C tutorials. I'm Hadi Pro from Uganda. If this is your first time, please go and look for the first videos that will help you to catch up. Don't forget to subscribe to my channel, and please don't forget to invite other members to also come and use this opportunity to learn how to program. Let's pray. Our dear kind and loving Father, we thank you for the wonderful time you have given us. We thank you for the breath of life. We thank you for the many good things you've done for us. We are going to study. We ask that you be with us in everything. Guide us, touch our brains and minds so that we understand each and everything. In Jesus' name we pray. Amen. Today, we're gonna look at operators and expressions. What's an operator? An operator is a symbol used to perform mathematical and logical operations in a program. It tells the compiler to perform mathematical or logical operations. So in C programming language, we have a set of operators and they are classified as follows. We have what we call the arithmetic operators, relational operators, logical operators, increment and decrement, assignment, bitwise, conditional, and spatial operators. Let's talk about each in detail. We have the arithmetic operators. These are symbols that are used to perform basic mathematical operations like addition, subtraction, multiplication, division, and the percentage modulo. This table tries to describe and explain by showing an example how each operator works. This addition operator can be used with numeric data types. So this is the addition operator. And when used with numeric values, it performs mathematical addition, and with character data type values, it performs concatenation. So we can use it just like in mathematics when we add 10 and 5 and we get 15. So plus is the operator. But again, we can use it with character data types. And there it is used for concatenation. We shall look at concatenation more in details. But concatenation briefly is joining two strings together. Then we have the subtraction operator. Just like in mathematics, we use it to subtract two values. For example, 10 minus 5, we get the 5. Then multiplication, we use that asterisk symbol or the star. So 5 times 10 gives us 50. Then you have division, we use that forward slash for the division symbol. And then we have this percentage modulo operator. Sometimes we call it the remainder of division. So in this operator, for example, when you have 5 modulus 2, the result is the remainder. So we are interested in the remainder of 5 divided by 2, and that is 1. So the remainder of division operator is used like so. We have relational operators. These are symbols used to compare two values. They are used to check the relationship between two values. Every relational operator has two results, either true or false. So in simple words, they define conditions in a program. This table tries to provide information about the relational operators. So you have the the less than sign, greater than, less than or equal to, greater than or equal to, the equal to. So for the equal to operator, we use double equal to signs. If it is only one equal to sign, then it's not equal to sign, but rather an assignment operator. Then this is not equal to operator. The description is there, and this is not new. For example, this is an example. 10 less than 5 is false, and 10 greater than 5, we know that in actual sense 10 is greater than 5, so that is true, and so on and so on. Then we have what we call the logical operators. These are symbols used to combine multiple conditions into one condition. this table still provides information about the logical operators. So we have what we call the logical AND, the logical OR, and the logical NOT. This logical AND returns true if only and only if all the conditions are true. So if any of the condition is false, then the complete condition becomes false. For example, here you are seeing the logical AND operator here, and these are the two conditions that we are comparing. So 10 less than 5, we first deal with this first condition. Is 10 less than 5? No. So meaning here we have false. What about here? Is 12 greater than 10? Yeah, so this is true. Now we have false and true will give us false, because the logical AND will only give true if and only if all the conditions are true. So if one condition is false, like for the first condition, then the final result will be false, much as the second condition is true. Then the logical OR returns false if all conditions are false, otherwise it will return true. So for the logical AND to return the true result, both for the logical AND to return the false result, both conditions that we are comparing have to be false. Is 10 less than 5? No. Is 12 greater than 10? Yes. Now when we say no or yes, we get yes, because for the logical AND, if this condition, like you see it, 10 less than 5 is false and the other condition is true, we return it true. As long as one of the conditions that we are comparing is true, the final result will be a true. Then the logical NOT returns true if the condition is false, and returns false if the condition is true. So the logical NOT is the negation. Before you look at the logical AND, you first get the result in the brackets, and now you reverse it or you invert that result. So look at these conditions, the conditions that we are comparing. 10 less than 5. Is 10 less than 5? Of course no. So we have false. And is 12 greater than 10? Of course yes. So we have a yes, a no, and a yes, or we have a false and a true. And since we are using the logical AND, the answer is false, because logical AND can only return true if both conditions that we are comparing are true. So since the AND will return a false, now we go to the negation. The opposite of false is true. So that's how this logical NOT will work. We have increment and decrement operators. Increment and decrement operators are called unary operators, and this is because they only work with one operand. This is what we call an operand. That symbol A, it can be a variable, it can be a value. For example, if you have A plus B, A and B are the operands and the plus is the operator. If you have 6 minus 7, 6 and 7 are the operands, whereas the minus is the operator. So the increment and decrement operators only work with single or one operands, like A plus plus. You don't need to have two operands, but A plus plus means A plus 1. And since, for example, here A is initialized with the value of 5, 5 plus 1 will give us 6. So A plus plus means A plus 1. And A minus minus means A minus 1. So A minus minus will give us 5, which is the initial value of A, minus the 1 to get the 4. So this table tries to explain all those details about the increment and decrement operators. Now the increment and decrement operators are used either in front of the operand or after the operand. If they are used in front of the operand, we call it the pre-increment or pre-decrement, and if they are used after the operand, we call it post-increment or post-decrement. Now let's talk about the pre-increment and pre-decrement. In case of pre-increment, the value of the variable is increased by 1 before the expression evaluation, and in case of pre-decrement, the value of the variable is decreased by 1 before the expression evaluation. So when you talk about pre, the increment is done before the expression evaluation. So we mean here that for pre-increment or pre-decrement, the first thing to do is that the value of the variable is incremented or decremented by 1. After doing that increment, then after that the modified value is used in the expression evaluation. Let's look at this example of pre-increment. We are gonna use our code blocks. So my code blocks is opened. We can start a new project. So we can click here to create a new project. Then we use the console application. We continue. We are using C. We continue. We can call our project Increment, and we can choose the folder. My folder is in Documents, C Programming. So we choose that, and then we click Next, Finish. Now, where are my projects? Okay, this is very simple. Now at times you may close this window here called the manager window. You may close it accidentally. So what you do is that you go to the view menu and look for manager, or you can just simply press Shift F2. So when you click the manager, this management window will appear again. So this is where your projects are. Remember, we have to expand this, and we double click on that main file .c to open our project. And don't forget, as we said, that these code blocks will write for us this hello world program by default. The standard input and output header file and the standard library files will also come by default, so we can leave them because for example, we need this one. Now we can just modify this to our program. I don't want to use int, let me use void for now. That means I won't need the return 0 statement. Okay, let me declare my variables. I can say int I assign it a value of 5, that's the initial value of I, comma j, and then I terminate. So what am I doing here? I'm initializing the variable I. In other words, I'm declaring two variables I and j. At the same time, I'm initializing variable I with an integer value of 5, or I'm assigning an integer value of 5 to variable I, and these two variables I and j have got an integer data type. Then I use this semicolon to show that I'm ending that statement. So that's how you can explain that line of code. Now let me assign this variable j something. I say j, then I put the assignment operator plus I. Then I terminate. What am I doing here? I'm assigning the pre-increment of I to my variable j. Then I want to write some simple comment. I can say that here I'm doing what we call the pre-increment. Now I'm going to print something here. So let me edit this. I delete that. I just simply want to print I equal to. Now the position where the value of I will be printed, I'm going to put the format specifier. Why am I using D? I is an integer, and the format specifier for an integer is D. Then I say comma. Then I also output the value of j. Still I will use %d because even j is declared as an integer variable. Then I put a comma, I put I still comma J. Note that the comma, the first comma here is put after the quotation marks. Now the first variable stores a value that will be displayed in this position, in the first position, and the second variable J is storing or holding a value that will be displayed in this second position. Now before I even run my program, what do I expect? For pre-increment, we first increment the value that we get, which has been modified, is the one that we assign to J, meaning that the I, which is 5, when we increment it, remember incrementing means increase by 1, even decrement means reduce by 1. So here we are using plus plus, meaning we are incrementing. So 5 plus 1 is 6, and 6 will be assigned to J, meaning we expect to display J equal to 6. What about for I? I has been already incremented, so by the time we print I, it will be 6. So we expect I equal to 6 and J equal to 6. Let's see that by building and running our program. So you see, I is 6, J is 6. Good. So that's how pre-increment works. Let's continue. So that's our example. Now what about post-increment or post-decrement? In case of post-increment, the value of the variable is increased by 1 after the expression evaluation. In case of post-decrement, the value of the variable is decreased by 1 after the expression evaluation. So this means that when we use post-increment or post-decrement, the first thing to do is that the expression is evaluated with existing value. Then after that, value of the variable is incremented or decremented by 1. First, the expression is evaluated with the existing value before the modification. After that, the value of the variable is incremented. So assignment first, then modification comes later, unlike the pre-increment or pre-decrement. Let's try to understand what this really means by using a code. So this is an example that we are going to type, and we see how it works. So let's go back to our code blocks. Now this time around, we don't need to create a new project. We're gonna just modify this existing one. We can leave the declaration statement as it is. Then here we change. We are no longer doing pre-increment, but rather post-increment. So we say I plus plus, and maybe we can change our comment that this is now post-increment. Okay, before we run our program, let's first try to understand and maybe guess what the result will be like. Remember, for post-increment, we first assign, then we modify, meaning that this J will be assigned the initial value of I, so J will be 5. Now we increment the I becomes 6. By the time we print, J will be having 5 because that's what was assigned to J. So expect J to be 5 and I to be 6 because by the time we print, I has been incremented. Let's try to see that. So when we run our program, there is what we get. I is 6, whereas J is 5. Good. So that's how the post-increment or post-decrement work. Let's continue. We have what we call the assignment operators. We have been using this assignment operator. Now let's try to understand and even look at other assignment operators. These operators are used to assign the right hand side value or the R value to the left hand side value or the L value. The assignment operator is used in different variants along with the arithmetic operators. So this assignment operator that you're seeing, we can use it with variants by accompanying the arithmetic operators before the assignment operator. For example, you have plus equal to minus equal to, multiplication equal to, division equal to, and then the remainder of division equal to. Okay, this one we know what it means. It is not equal to, but we are simply saying that a variable f, for example here, is given a value of 15. Why is it not called equal to? Remember, this variable stores different value at a time. This value can be changed to 16, to 20. So a is not equal to 15, but we can give it, it can hold that value at a time. So that's what that means. Now, what if we put a plus before the assignment operator? What does that mean? We are saying that add both the left and the right hand side values. Thereafter, store the value into the left hand side variable. So when we say a plus equal to 10, add a, which is on the left, to to 10, which is on the right. So that is a plus 10. What you get, assign it to the value on the right, assign it to a. The same applies to subtraction and all these. The logic is the same. So that's how the assignment operators work. Let's talk about the bitwise operators. The bitwise operators are used to perform bit-level operations in C programming language. When we use the bitwise operators, the operations are performed based on the binary values. This table tries to describe all the bitwise operators in C programming language. We're gonna consider two variables, a and b, whereby a has a value of 25 and b has a value of 20. And this is in decimal. In binary it is 11001, and 20 in binary is 10100. Remember, we are saying that bitwise operators perform bit level operations. So let's try and see how these operators, the bitwise operators, work. We have the bitwise AND, the bitwise OR, bitwise XOR, bitwise ones complement, the bitwise left shift, and the bitwise right shift. Now note that the bitwise AND resembles the logical AND, but this time we only use a single symbol, and even the OR we use a single symbol. So take note that difference. Now when we are using a bitwise AND, how is the expression done? We are saying that the result of the bitwise AND is 1. If all the bits are 1, otherwise it is a 0. So we only get a 1 if the if the bits that we are joining using the AND are both 1s. Otherwise we have a 0. Let's try to understand by looking at this example. Okay, now we have A and B. We are going to use the bitwise and dig it by digit, because we said they perform bit level operations. So we have the 1 and the 1. Remember, a 1 and a 1 will give us a 1, because we said the result is 1 if all bits are 1. So we are saying 1 and 1, meaning we expect to get a 1. So that's the 1 here. Now we have a 1 and a 0. Since we have only 1 and the other one is a 0, we get a 0. We can only get a 1 if all the bits are 1. What about this 0 and a 1? Still we get 0. What about this 0 and a 0? Still we get 0. And what about this 1 and a 0? Still we shall get a 0. So that's how we arrive at 16 in decimal and 10000 in binary. So that's how the bitwise AND works. Now again, we can see how the bitwise OR works. The bitwise OR will result in a 0 if all the bits are 0. Otherwise it is 1. So it's the opposite of the bitwise AND. We only get a 0 if all the bits are zeros. Any other case, 0 and a 1 or 1 and a 0, we get a 1. Even 1 and a 1, we get a 1. Let's look at our example again. We are this time using the OR. So we have 1 or 1. What do we expect to get? 1 or 1? A 1, as we have said here. And 1 or 0, still a 1. And then 0 or a 1, still a 1. Okay, I have skipped this one. Okay, this is 0 and a 1. We have a 1, that one here. And then this is 0 and a 0. So when we have the 0 and the 0, as we said here, that's when we get that 0. Then we have a 1 and a 0 to give us a 1. So that's how the bitwise OR works. Then we have the bitwise XOR. The result of the bitwise XOR is 0 if all the bits are the same, otherwise it is a 1. So the bitwise XOR, as long as the bits are similar, are the same, we shall get a 0. If they are not the same, we get a 1. So let's try to see. A 1 and a 1, they are the same. So what do we expect to get? A 0. As we said, a 1 and a 0, they are not the same. So we have a 1. A 0 and a 1, they are not the same. We have a 1. Another 0 and a 0, they are the same. We have a 0. And a 1 and a 0, the bits are not the same, so that's why we have a 1. So that's how the bitwise XOR works. Then you have the bitwise ones complement. This is a negation of the bit. For example, we use this symbol and we negate variable a. A is the one which is 11001. The negation is the inverse, the opposite. So the 1 will become a 0. The opposite of 1 is a 0. The negation of a 0, no, sorry, another one still a 0. The negation of a 0 now becomes the 1. Negation of another 0 is a 1. And the negation of a 1 is a 0. So that's how the bitwise ones complement. That's how it works. Then we have the bitwise left shift operator. This shifts all the bits to the left by the specified number of positions. So we are just shifting bits, all of them, to the left because it's a left shift operator, bitwise left shift, by the specified number of positions. So we have a bitwise left shift 2, meaning we shift all the digits of a to the left by 2 positions. So my friends, this direction here is the what? The left, and this direction is the right. So this is the right and this is the left. So this bitwise left shift will shift to this position of the left. So we are looking at a is what we are using, 11001. When we shift to the left by 2 positions, that means we shall create 2 positions here which are empty. So that's why we put the zeros, and whenever we do the left shift, the positions that we create are significant. So that's why these zeros here are very important and we put them there. But again, for the bitwise right shift, it does the same thing, but this time it does it in the right direction. So when we shift a by 2 positions using the bitwise right shift operator, a is 11001. So you have 11001 0, you are seeing 1 1 0. Now these two positions, the 0 and the 1, are shifted to the right, so we trim it, we cut them off and create two positions after. So you have the 0 0 1 1 0. Now these two positions here are non-significant. When you shift to the right, these values that you create, the zeros, are not significant, meaning even if you just write 1 1 0, still it is the same as 0 0. Even if you put 1,000 zeros before, they are not important, but this is shown here for the purposes of understanding. Okay, we can continue to another type of operator. Now, okay, we have what we call the conditional operator. The conditional operator is also called a ternary operator. This is because it requires 3 operands, as we are going to see. It requires 3 operands. Remember the unary operator. Unary means 1, so it requires 1 operand, like the increment and decrement. But now ternary requires 3 operands, so that's why you call it the ternary operator or the conditional operator. This operator is used for decision making. In this operator, first we verify a condition, then we perform one operation out of the 2 operations based on the condition result. Now, if the condition is true, the first option is performed, and if the condition is false, the second option is performed. The conditional operator is used with the following syntax. So you have the condition, then you have the question mark, the true part, then you have a colon to separate the true part from the false part. This is an example. We have A as our variable, and we are assigning it either 100 or 200 depending on this condition. So these are the 3 operands that are required. We have this operand A, this operand, and this operand. Now we have our condition here. We ask ourselves, is 10 less than 15? So it is like we are asking, you are saying a question mark, is 10 less than 15? Of course, we know that the answer is true. The answer is a yes. 10 is really less than 15. So the true part, which is 100, will be assigned to our variable A. Now, if 10 is not less than 15, then the false part, the 200, will be assigned to A. But now for our example, the true part, the condition gives us a true result, so the true part will be assigned to variable A. Let's try this out using code blocks. Okay, we are gonna just edit our code and then we try it out. Okay, we can leave our main function there as it is. We can declare a variable A. I want to use the same example as the one that I've showed you. Okay, we have int A. I can terminate it. Now we are going to assign it A, the true part or false part, depending on the position that depending on the condition that we are going to give. So this is our condition. We have 10 less than 15. We are asking if that is true, then this 100 will be assigned to A, and if it is false, the 200 will be assigned to A. So we terminate, and now here we want to display something to the user. Maybe we can say the value of A is, then we put our format specifier. We are using D because A is an integer, and now here we put the variable A, which variable holds the value that will be displayed within that position where we have the format specifier. So when we run, we expect a statement to be displayed saying that the value of A is 100 because the condition is true, so the true part will be displayed. Let's use build and run to effect our changes and see how that works. So when we run our program, this is the result, that the value of A is 100. Wow, that's good. Now we can try to change this condition. If I use the greater than symbol, is 10 greater than 15? Of course no. So the false part, the 200, is expected to be assigned to A. Let's try it out. Okay, so you are seeing that the value of A is this time around 200. So that's how the conditional operator works. Okay, let's continue, friends. We have what we call spatial operators in C. These spatial operators include the size of pointer operator, comma operator, and the dot operator. We will again make more research and see how they are used, but I'm going to talk about them briefly. The size of operator is used to find the size of memory in bytes that is allocated for a variable. The pointer operator is used to define the pointer variables in C programming language, whereas the comma operators is used to separate the variables while they are declaring them, and it's also used to separate expressions or functions. For example, when we say int a, comma b, comma c, and then we terminate, in that one statement we are declaring three variables a, b, and c once, and we are using the comma operator to separate them. So that's an example of how the comma operator works. Now the dot operator is used to access members of a structure or a union. We shall look at some of these as we continue. Okay, now let's talk about expressions in C. In any programming language, if you want to perform any calculation or to frame any condition, we use a set of symbols to perform the task. This set of symbols makes an expression. Now, an expression is a collection of operators and operands that represent a specific value. An operator is a symbol which performs tasks like arithmetic operations, logic operations, and conditional operations, among others. We've already seen operators. And an operand is a value on which the operator performs the task. So here the operand can be a directive value or a variable or address of memory. It can be a directive value just like 5, 6, 10, 100, negative 10, or it can be a variable like a, like a word, average, sum, total, and so on. Let's talk about the types of expressions in C. In C programming language, expressions are divided into three types, and these are infix expression, postfix expression, and prefix expression. This classification is based on the operator position in the expression. The position where the operator is in an expression determines this classification that we are talking about. So let's talk about the infix expression. These expressions have the operator between the operands. As you see them, the operator, the plus, is between A and B, which are the operands. For postfix, the operator is after the operands, and for prefix, the operator is before the operands. Let's talk about operator precedence and associativity. Now, operator precedence is used to determine the order of operators. It's used to determine the order in which operators are evaluated in an expression. In C programming language, every operator has precedence priority. It has precedence or priority. So in short, precedence is the priority. What does this mean? When there is more than one operator in an expression, the operator with higher precedence is evaluated first, and the operator with least precedence is evaluated last. What about operator associativity? Now this one is used to determine the order of operators. It's used to determine the order in which operators with equal precedence are evaluated in an expression. So in C programming language, when you encounter an expression which contains multiple operators and these operators have equal precedence, we use what we call the associativity to determine the order of evaluation of those operators. This table here is trying to show the operator precedence and associativity. You will go through it, the all of it, but this is how C evaluates the expressions using this operator precedence and associativity. So these operators have the first priority, these ones have the second priority or a higher incidence than these ones, up to this, the separator operator. So the brackets, the function calls, arrow difference, and so on have the highest of precedence, and their associativity is that they are evaluated from left to right. Now that means, for example, here when you encounter, these ones are very common, they are at level 3 of precedence and their evaluation is left to right, meaning when you have the multiplication and the division operators in the same expression, since they have the same level of precedence, you look at which operator is on the left, you begin with it, because we begin from left going to right. So that's what we mean here. Let's continue. So here we have an example of an expression, and we're gonna use the precedence and associativity to see how we can evaluate this expression. As we have said, expressions are evaluated basing on the operator precedence and associativity. When there are multiple operators in an expression, they are evaluated according to their precedence and associativity. So the operator with higher precedence is evaluated first, and then the operator with the least precedence evaluated last. So in this example, you're seeing that we have 3 operators. So we have our 3 operators, and what are they? These operators, we have the plus, so that's our first operator. We have the asterisk or the multiplication operator, and then the division operator. So those are our 3 operators, and among these 3 operators, both multiplication and division have the same level of precedence. So this multiplication and division have the same level of precedence, whereas this addition has a lower level. So according to the operator precedence, both multiplication and division have to be evaluated first, and then addition is evaluated. So what do we do? Okay, now as multiplication and division have the same precedence, they are evaluated based on the associativity. And here, if you go back to our table, the associativity of multiplication and division is left to right. So multiplication is performed first, then division, and finally addition. So in the above expression, in that expression, we evaluate multiplication and division first, then subtraction, as you see here. Okay, so here you are seeing 4 times 3. We have chosen multiplication over division, because multiplication is on the left and division is on the right. So 4 times 3 giving us 12. Now we go to division. 12 divided by 2 giving us 6. Now we come to the addition, 10 plus the 6, we get the 16. So our answer is finally 16. Now this precedence and associativity are like what we call body mass in mathematics, but again they do differ a bit. So don't follow body mass, follow what C has is if you are writing a C program. Okay, we can continue. Let's talk about type casting and conversion. Now, C expressions can contain data values of the same data type or different data types. When the expression contains similar data type values, then it is evaluated without any problem. But if an expression contains 2 or more different data types, then they must be converted to a single data type of destination data type. So here, the destination is the location where the final result of that expression is stored. For example, the multiplication of an integer data with a float data value and storing the result into a float variable. So in this case, the integer value must be converted to the float value so that the final result is a float data value. So that's how C programming does things. Now in C programming language, the data conversion is performed in 2 different methods as follows. So we have what we call the type conversion and type casting. Okay, let's begin with type conversion. Type conversion is the process of converting a data value from one data type to another data type automatically by the compiler. Sometimes type conversion is also called implicit type conversion. For example, we call it implicit type conversion because this conversion is done automatically by the compiler. For example, when we assign an integer value to a float variable, the integer value is automatically converted to a float value, and this is done by adding zeros or a 0 to the decimal value. And when a float value, for example, is assigned to an integer variable, the float value automatically gets converted to integer value by removing the decimal value. Okay, we can still look at that in detail. Look at this example. We have a simple code, int I, and I has a value of 10. So this I is a variable with an integer data type, and it is declared and assigned a value of 10. Here we are declaring variable x with a float data type, and we are assigning it a float value of 15.5. Then we terminate, and here we are declaring a variable called ch, and this ch has the char or the character data type. And remember, for character we enclose the value in single quotes, and then we terminate. So this character variable, the ch, is assigned a value of a. So here we are trying to see how implicit type conversion works. Now I, if is assigned x, I is integer. If we assign it x, which x is 15.5, we are assigning a float to an integer. We are saying that this value 15.5 is gonna be converted to 15, and then it will be assigned to the variable, and the compiler will do that automatically. So this is what we call implicit type conversion. And if x, which is a float variable, is assigned I, so if we assign 10, which is stored in I, to x, since x is a float, this value of 10 is gonna be converted from float 10 to, no, from integer 10 to a float 10.00. There are 6 zeros for a float. Okay, and then it will be assigned to x. Now I, if it is assigned to assigned ch, ch is char, a character, which is a. Now if we assign a to I, which I is an integer, so here the ASCII value, ASCII is American Standard Code for Information Interchange, that each value on the keyboard has got its equivalent ASCII value. So for A, that value is 65. It is that integer value, the ASCII value of A, that's gonna be assigned to variable I. Let's look at an example. In this example, we are going to see how implicit type conversion works. Okay, now let me use, again, I'm gonna go to my code blocks and try to see how we can work out this program. Okay, that's my code blocks. Again, let me just, okay, this time maybe let me create a new project. Okay, new project, a console application. We click next. My language is C. I click next. The title, I can call it type conversion. This is where my project is, or where I store my projects. Then I click next and I finish. So now I go to this, I double click main to open the main.c file, which is created by code blocks by default. So this is the other program. This is another one. Let me even close this one. Okay, now let me edit this one. I like using void, and I eliminate the return 0. Okay, let me begin by declaring my variables and assigning them the initial values. I can say int I, and I assign it a value of 95. I terminate. Then I say float x, I assign it a value of 90.99. I terminate. Then char ch, I assign it a character capital A, and then I terminate. Now if I try to assign I to, I assign it a variable x, or assign variable x to I, let me just edit this print a function instead of hello world. Let me say I value is, I is an integer, so I use the format specifier for integer, which is %d. I put the /n so that the next result will go on the second line. Then I put a comma, I put I, which I is the variable that stores a value that will be displayed in this position. Then as I assign x a variable I. Okay, so I can say printf, okay, x value is, since x is a float, I have to use the float specifier for float, which is %f, still /n, and then comma, I put x. Okay, then again if I assign I the ch variable, then I still print. Okay, so I can say I value, is this I? Yeah, I value. Okay, this word is not value. I value is still I is I is an integer, so I use %d. I can still use the /n, though it may not be necessary here. Then I put a comma and I put I. Okay, now let's run. Remember, we are just testing what we've already explained. So when you run our program, this is what we get. I value is 90. Remember I value is 90. X value is 90.000, and I value here is 65. That's the ASCII value of A. Now X, when you look at X here, is a float, 90.999. But now that X here is given I, which I is an int, but X is a float, so the int will be converted to a float. That's why you are seeing the zeros, and this 90.99, which is in float, when we assign it to I, like here we are assigning that 90.99, which is in X, to I. Since I is an integer, it will convert this to an integer. Now instead of 90.99, that's why you have the 90 when we have trimmed off the decimal places. So that's how the implicit type conversion works. Okay, we can continue with our presentation. Now let's talk about the type casting. This is the second method under type conversion. It is also called the explicit type conversion. The other one was implicit, which is done automatically by the compiler, but this one is explicit type conversion. So here the compiler will convert data from one data type to another data type explicitly, but not automatically, not implicitly. So when the compiler, as we have seen, when the compiler converts implicitly, there may be data loss. We have already seen that, where the 90.99 was trimmed and it became only 90. So there might be data loss. Now in such a case, it's very advised or advisable to convert the data from one data type to another using the explicit type conversion. And to perform this, we use the Unarycast operator. So we are going to see how that Unarycast operator is used. So to convert the data from one type to another type, we specify the target data type in the parentheses as the prefix to the data value that has to be converted. So this is the general syntax. You put the target data type. If you want to convert to float, you put the word float in these parentheses. Then you put the data value that you wanna convert. Let's look at this example. You have this simple program. Now in this example of code, both total marks and max marks are integer data values. So you're seeing total marks assigned 450 and declared as an integer variable, and you have another integer variable on the same line that we are declaring called the max marks, and still initialized with an integer value of 600. So both max marks and total marks are integer variables, excuse me, whereas the float is the average is a float variable. Now when we perform total marks here total marks over or divided by maximum marks. The result that we expect is an integer. But remember, in reality, 450 divided by 600, the answer you get on the calculator is not an integer, it has decimal points. But since we have declared them as integers, we shall get an integer result. But our destination, the float, no, the average is a float, because in reality the average is a float. So what do we do here? We introduce what we call typo casting to convert the total marks and max marks, the division of total marks, and we call it the quotient of total marks and max marks, into the float data type. Let's look at this example, and I think this will mark the end of our class. Still, let's go to our code blocks and see what we can do. I'm just gonna change this existing code and I modify it. So in this example, we are going to try to see the average of three numbers before casting and after casting. All implicit, no, this is explicit type conversion, which we call the type casting. Okay, we are gonna declare three variables with integer data types. We have variable A, B, and C. So I think you're seeing how we are using the comma operator. And then we terminate. Then we also declare AVG, meaning average, as a float. Okay, AVG as a float. Let's terminate it. And thereafter, let's print something, some message to tell the user to enter the numbers. So to do that, we use the output function called printf. Now you also realize that this code blocks has some element of what we call Intellisense. It can sense, it is intelligent. The moment you type, for example, you try to type print, the printf or some other functions or keywords that begin with print or p will appear. So you can use the tab key on your keyboard to select what is highlighted so that you save your time on typing. So let's tell the user to enter any three integer values. So we can say enter any three integer values. Okay, we can even put /n so that we take the user to a new line, and then we terminate. Now after entering, that is just a message that we are telling the user. We display using the printf. We have to store what the user has just entered, and we have to tell the compiler that the first integer the user has entered is stored in A, the second integer should be stored in B, and the third integer should be stored in C. How do you do that? We use the input function called scanf. Okay, so scanf, we open quotes, and inside the quotes we put all the format specifiers for the variables, and all our three variables A, B, and C are integers, so we use %d for all of them, %d, three of them. Okay, and a comma, the first position %d is holding for variable A. So how do you tell the compiler that where you are seeing %d, the first %d is a position kept for the value stored in variable A? We do that by putting the ampersand symbol followed by our variable A. Then for the second position, this one, the second %d is holding, is keeping the position for variable B. So we still do the same thing, ampersand B, then we put another comma, and then ampersand C. Okay, so that's how we tell the compiler that what has been entered first will be stored in A, then second in B, and third in C. Now we assign our average. You know, average is total number of items over the number of items. So AVG is assigned. Of course, we can introduce these parentheses, A plus B plus C, then divide by 3. Because they are 3 items, we divide by the number of items, which is 3, then we terminate. Okay, so that's our average, and this average is before type casting. Okay, let me modify this print a function. Okay, I can say the average before casting is, then I put the position where that average will be stored. Since my average is declared as float, so I use %f, not %d, then comma, I put that variable that stores the average, which is avg. Now again, let's introduce the typecasting. This time around, we use that operator that we have talked about with float. So we are typecasting. That means what follows after this float will be converted to a float. Okay, so still we do the same, A plus B plus C divided by F3, and then we terminate. Okay, I don't need these. So we can say again that the average after casting is, okay, here let me even put /n to take it to, so that this second statement will be displayed on a new line. So is still our average is a float, so we use %f as the format specifier for float data type, and then after the comma we put our average variable. Okay, now let's see the difference after casting and before casting. Okay, let me run. So you are seeing enter any 3 integer values. So I put maybe 78, I press enter, 90, enter, 4. When I press enter, the average before casting is 57. Now much as our average here is a float, but we have not done any type casting, our final answer will be a float, but we have lost data. The decimal places are nowhere to be seen. Why? A plus B plus C, all these 3 variables are integers. So still when you divide by 3, in the calculator we expect to get decimal points, but since they are integers, the final result that we get will be an integer. And when we assign it to a float, it will come as a float, but we have lost data because the decimal places are trimmed off. And here we are not okay, we are not rounding off, no, we just trim. But now after casting, what the result that we get here will already be a float. So by the time we assign it to AVG, it is already a float because we have done the type casting. So that's why we get 57.333 and then a 2. So you're seeing the difference between casting and before casting. So you're seeing the beauty of using the explicit type conversion, or what we call the type casting. So my programmers, as a desirable program, I program, or if you're writing desirable computer programs, they should not lead to loss of data, so you'll be using typecasting a lot. My friends, I thank you once again for following me. Thank you for watching. Invite more friends to come and also watch and get to know how C programming is done. Don't forget to subscribe to my channel, and remember that when the going gets tough, the tough get going. Have a good day.